Okay, this next section is about, in contrast to cellular immunity, is called humoral immunity. And it is an indirect method. It's very similar, has some same features as cellular immunity, but it is an indirect method of defense. So here, instead of T cells, we'll be seeing B cells. They're still lymphocytes, but B cells producing antibodies. Those antibodies are what is going to bind to the antigens and tag them for destruction by other cells. So the cellular immunity, remember from the previous video, attacks the enemy cells directly. Like cellular immunity, we'll see the same 3 stages. Now, I will say your book goes into a lot of detail in some of these stages, especially in the attack stage, and we will be skipping through some of that. So the recognition stage here looks similar to what it did in cellular immunity. Those B cells, once they're able to detect certain antigens, they are let loose and they have thousands of surface receptors for one antigen. And so the activation begins when the antigen binds to several receptors and links it together, just like we saw in cellular immunity. Then it's brought into the cell by endocytosis, and then the B cell digests the antigens. Then it links some of those epitopes to the outside, those proteins, and displays them on the cell surface to show what type of cell this is. Once the B cells are activated and they bind, they also need a helper T cell to bind to that protein complex on the outside of the cell. And so once the helper T cell binds, then they secrete those proteins called interleukins, and they are activating the B cell to do the cloning, just like we saw in cellular immunity. So the B cell is going through mitosis to make more and more B cells. Most of those are going to differentiate and become plasma cells, and they are going to produce antibodies, and they will live a life of 4 to 5 days. Others are going to become memory B cells, and they are going to survive for decades, keeping the memory of that specific antigen. Okay, so from recognition, we're moving into attack. This is specifically attack of the plasma cells. The antibodies are going to bind to the antigen and render it harmless, and then tag it for destruction. So they are going to, from there, keep a memory of what that antigen is. If that antigen returns, the plasma cells are produced very quickly and arrive at the scene. Okay, here's where in the attack portion of this stage, what we just did was just talking about plasma cells. This is then moving into just antibodies in general. And it gives a very long, very specific kind of background about antibodies. And so I would encourage you to read through this, but also I don't need you to memorize the 5 classes of antibodies. I don't need you to memorize, that mucus is IgA. No, we don't. We have to cut certain things off at a certain point, and this is one of them. So looking at how antibodies make those antigens harmless. That plasma cell, it just said it renders it harmless. Well, how does that happen? There's 4 ways, and these are very similar. Especially the second part, is very similar to what we saw in the non-specific resistance video. So here are the ways that they render the antigen harmless. So neutralization, they can basically, the part of the antigen that makes it a pathogen, they mask that. So they kind of cover that part up. So that's considered neutralization. An antigen is also able to initiate that complement system that we saw back in non-specific resistance that had the 4 mechanisms: inflammation, phagocytosis, immune clearance, or cytolysis. So all of those ways were essentially a way that the antigen gets destroyed, for lack of a better word, but it is our primary defense against foreign cells, bacteria, and red blood cells that are not the correct type. And then the last two mechanisms of attack are agglutination. The antibody has binding sites. It can bind to enemy cells and preventing them from spreading. And then also precipitation. The antibody is able to bind to the antigens, not the cells, but it makes that antigen-antibody complex, and then that complex is what the eosinophils are able to find and destroy through phagocytosis. And then the last stage of the immunity is memory. And so just very similar to what we saw in cellular immunity, the immune reaction the first time is called the primary immune response, but we would then expect from those memory cells to the secondary response is going to be much faster because those B cells are memory B cells. They are going to live long, and they are able to mount a very quick secondary response because they are ready whenever needed. So the secondary response occurs with the re-exposure of the same antigen. So the plasma cells form within hours, and again, just like we saw with cellular immunity, there's not going to result in any illness because the response is so fast.